we're continuing our conversations with great companies and great projects in the industry. That's another take from Logan Utah SmallSat Show 2019. With me today is Doug Liddle from In-Space Missions Company, based in United Kingdom. And we're going to talk about an alternative way to test your payloads in orbit and hopefully deliver it on a very good timescale and really on a budget. So, Doug, could you tell us a little bit about yourself, where you're coming from, and then we can discuss your business.
Okay. Well, I'm British. I've been in the space sector since 1994, initially in military space, working with the UK government and the Ministry of Defence. And then I moved to Surrey Satellites, who are the world-leading manufacturer of small satellites. Yeah. So I joined there in 2001. Initially as a systems engineer, and then as time went on, I was the lead engineer on the Jovi project, which was Europe's first Galileo demonstrator. Developed a small geostationary telecommunications platform. Then took a bit of a turn, started getting involved in science and exploration, small satellites, devised the Strand 1 mission, which was the UK's first CubeSat.
And, when was that?
So Strand 1 was, I'm going to get it wrong now, 2014. Wow. 2015, yeah. So we put that up, very exciting mission. And then also in a similar time period, I was doing Tech Demosat 1, which was one of the UK's technology demonstration hosted payload missions, which was funded by the UK government at the time. But we saw the potential in that of putting multiple payloads onto one satellite and the benefits you could get from doing that and offering a lot of people a ride at a low cost.
So multiple, meaning different payloads from different institutions.
Different payloads from different institutions, customers.
Different purposes.
Doing different things on the spacecraft. And then 2015, I decided to leave Surrey Satellites just for a new challenge, really. So I set up my own company, which I now have a co-owner. And we are not only offering initially consultancy to government and institutional guys, but then we kind of moved on and started realizing that we missed building spacecraft, because in our past we built a lot of spacecraft.
So you started as a consulting agency helping others to deliver the mission success, then and
initially it was government, but then it also became that we were talking to a lot of small companies and startups too, who had fantastic ideas for missions but hadn't necessarily built spacecraft before.
Right.
So we were able to come in and say, no, do this or this, and this will help, and offer different levels of advice.
Yeah.
But then we started building our own spacecraft, and we've devised the Faraday 1 service, or the Faraday service, sorry. So Faraday 1 is the first satellite we've built. We've got 7 payloads from 7 different customers.
So basically the same concept that you used to have.
But this time, instead of being something sort of built using government money, this is all built using commercial money. So people pay us money, we put them on the spacecraft, and we launch them. And then enough people join us on the mission that the mission covers its costs commercially.
And you have some profit.
And we have some profit. And actually, we only really enter profit after about 6 months, which is really interesting. So we kind of rely on the fact that people will want to carry on using space as a service once they've been up with us for 6 months. So when we sell a ticket to fly with us, you get all the support with payload build. You then bring your payload along, we integrate it, we test it, we do all the licensing, regulatory stuff, sort out third-party liability insurance, we buy the launch, we then operate you for 6 months. After 6 months, if you want, you could turn the payload off, and that's fine. You know, that's what you've bought by buying a ticket to fly with us.
Right.
But if you want to keep using the spacecraft because, you know, maybe you've initiated a service and actually people are buying your service, you want to keep using that while you raise the funding to launch another 20 spacecraft, you can use our spacecraft still, and you pay us and you keep using the spacecraft, and it kind of becomes satellite 0 in your constellation.
Right.
So, you know, now you've got a satellite
we call it MVP, like minimal viable product.
Yeah, it kind of is that, yeah. I mean, it might not even be the MVP. It might just be the same thing that you're going to build more of. But whatever, it's stimulated that market, and it's allowed you to then go out, raise the funding, and, you know, create a service, a constellation, make a lot of money.
But does it mean that your ideal customer would not be those customers that want just, you know, to turn on their satellite, take a few images with their camera, and then they're done?
No, we need a good mix.
Yeah.
So we like the guys that want to come up and just do 6 months, and that's great. Because they've got a very clear vision. They need to get up, they need to qualify their hardware quite often. They need to do a short duration test, whatever. And by them turning off after 6 months, we've got more spacecraft capacity to support the other guys. So our ideal situation is probably about half the people want to keep going after 6 months, and about half the people want to turn off.
You keep the rights to use, if they decide to shut it down, you keep the rights to use their payload?
Nope, it's their payload. So it's completely owned by them. They keep the rights to use that payload.
But if you find the customer for their data, then
then we would talk to the payload provider and say, hey, these guys want your data. What do you want to do? And we'll broker that discussion.
Are you really want to switch it off, or
Yeah, exactly.
Very good. So why would someone like a young startup from Europe or abroad decide to work with you guys instead of building their own satellite and launching it as a free flying body?
So a lot of it is around cost and schedule. So by sharing a spacecraft, you get something that's going to be about 20%. It's going to cost you about 20% as much to be able to share a spacecraft and use that rather than build your own spacecraft. And I'll work that through in a minute. But you probably get about 80-90% of the value of having your own spacecraft in terms of being able to turn on your payload. So as an example, say you had a 1 kilogram payload. You can fly that with us at the moment for somewhere between $100,000 and $200,000, and that'll get you 6 months in orbit. You compare trying to get a 1 kilo payload into orbit on your own. You're going to need something like a 3U bus. You're going to have to develop that bus yourself from scratch or buy that from somebody. That's going to take you quite a long period. You're then going to do all the licensing yourself, all the regulatory stuff. You're going to have to buy a launch. You're going to have to sort out an operation solution. Easily $500,000.
So unless that was your initial goal to go through that, it doesn't really, it's an added cost to your business.
And some people, they want to learn how to develop a spacecraft.
Yeah, which is fine.
And in which case, we're not for them, you know? Well, we are, but it's not the Faraday service. We'll work with them to help them develop a spacecraft.
Right, exactly, because you still retain that consulting business where you started with.
But, it's not the Faraday service because they want their own free-flying spacecraft.
Right.
But, if they want something that's going to be sort of maybe 20% of the cost, they come and talk to us.
Yeah, why not? 20% sounds good. Sounds like a deal to me,
and the schedule's good. So we're trying to, as much as possible, reuse existing avionics where we can. We're able to turn things around. At the moment, we've demonstrated recently that from signing a contract, having the spacecraft ready to launch, we've managed to sign our latest contract was 4 months before launch.
Wow.
So, the thing there that's the long part of the schedule is actually the regulatory piece. So getting all the licensing. Right. But the actual physical building
but you do care of that as well, right?
And we take care of that.
Yeah.
So that's fine.
Great.
And we have a very well-structured approach to the regulatory environment.
Okay. Sounds a little bit fishy to me. What's the downside? Like, what's
the downside?
Something could be wrong here. Should be wrong here.
So there is something wrong. I mean, the downside is you're going to have compromises. So, for instance, if you have a payload which needs to broadcast 24/7, it needs to be, something transmitting all the time, very loudly from the spacecraft. There are some other payloads in the spacecraft that are not going to be compatible with you.
So you have to be qualified for that particular instance of Faraday mission.
And we try and matchmake. We try to make sure we've got the right mix of payloads.
Yeah.
So there might be that, you cannot turn on over Brazil because we have a customer that always wants to listen with a payload when they're over Brazil. And we would have a discussion with you and say, can you live with that? And it might turn out actually you can listen in the daytime, but not at night time when you go over. So
but also you have to matchmake them for the same inclination as well. Right? It starts with inclination, and then you have to matchmake them between what these small payloads do together.
But most payloads, I mean, if we try to baseline a sun-synchronous orbit, because most payloads work with that, it simplifies the power and thermal design for the spacecraft. It opens up a lot more launches for us. So sun-synchronous is good. Saying that, we're not always in sun-synchronous in our missions, but we would target that. Then we try to get the right LTAN, make sure that the node is good. Some people don't want to be kind of on the terminator. There's various reasons. It might be lighting conditions. It might be ionospheric conditions. There are reasons.
Yeah.
So we work through that with the customers, and we try to find the right fit for them.
But we can mix the communication payloads and the observation on one
bus.
Those
are perfect. So ones that are optically imaging and ones that are using RF, they're our favourites because we can put those together and till the cars come home. That's easy.
Right. But I can imagine that timing might be an issue. So because you have to wait till the full bus is filled with paying customers, right?
And that was certainly true with the first satellite. But now we're getting into a situation where we're building several a year. So there is always another bus coming. And by, so next year we're hoping to launch 5. The following year, we're expecting to have even more.
5 payloads or 5 missions?
5 missions.
Wow.
So 5 satellites.
Every satellite will have a couple of payloads on it.
Absolutely.
Wow. That's big.
Well, we found a lot of demand out of it.
Why didn't you call yourself like a mixed constellation and, be another mega constellation in that case, Why not? You have everything that's usually describes a constellation,
Yeah, but also, our appetite isn't to be a mass producer of satellites. So we still rely on the fact, our first spacecraft, we use avionics from GomSpace, which are a great set of avionics. They've been approved by ESA on GomX4, so we know they're good, reliable avionics. We've got no desire to start building our own onboard computers. Now, if we're going to start building constellations, we need a really low-cost supply of some of these pieces of kit.
Right. So it's different, I would say, cost structure should be.
We'll do 4 or 5 satellites a year, I think, maybe a few more, but fundamentally we're not going to start building our own computers, our own power systems. We like to work with people that do that, and we integrate it and we test it and we tune it for the right payloads. So we don't want to just hand it over to somebody else, but we'll buy in their subsystems and we'll turn it into a spacecraft.
So when do you guys are planning to make the first launch?
So our first launch should have been about now. There's been a few production delays, so Rocket Lab's pushed us out to December. These things happen. So we'll be launching December this year, which will be our first commercial launch of this. And then, like I say, we've got another 5 next year, which is going to be really exciting. Just to quickly come back to the other point, there was one thing I was going to say, which is the one thing we also like doing is at the end of doing these demonstration programs, we want to hand customers on to somebody who's a manufacturer. So we can easily see a situation where GOM or Clyde or Nano Avionics or ISIS or any of these guys, we basically get to the end of working with a customer and then we introduce them and say, right, these are the guys that are going to build your 200 satellites now. It's not us,
Why didn't you want to? Why you're willing to handle off this great client of yours to other satellite manufacturers?
We like doing the fun, exciting stuff. We're old guys now, and we find this is where the challenge is. This is a place in the market where we don't really see much competition.
Right.
So people that have got a lot of experience that know how to make different, very complicated payloads work with each other.
Right.
This isn't a simple thing to do. This is a real challenge.
Yeah. So basically, you're providing a fast track to tech demo missions, fast track to fast revenue. Fast track to understand whether what they've willing to do in their business model is actually a viable model or not, right?
Absolutely. And we don't see competition in that bit of the market. If we were to become a satellite manufacturer, and we've done this, we worked at Surrey Satellites, most of the team are ex-Surrey guys. That market is already choked with really good manufacturers who are, all of them are ready to build 200 spacecraft.
Right.
We don't think we can add anything to that.
Yeah.
But what we can add to is the fact that we've got a small company, which effectively most of the guys in the company are 20 years experience and 30 missions under their belts, and they can bring that experience to bear on some really difficult problems.
And how big is your team now?
So we are only 7.
Only 7, wow.
But and this is another thing, we this is where we annoy some of our friends, because we don't see the need really for some of the big primes anymore. And we work by collaborating. So for instance, the team that delivers our software isn't in-house. It's a company called Bright Ascension, who we really like, we work with really well. They do fantastic work, and they work as an extension of us, and vice versa. We work together on quite a few things. So it's a really nice situation that you can put together a few smaller companies and create the capability of a prime, but you don't have to carry a standing army. Because this is always the danger, and I've seen this in previous companies, that you hire 30 people to build your mechanical design team, and then suddenly you're not doing a mechanical design project. So what do? Do you fire these people, or do you start inventing work for them to do? So we don't want to be that kind of company.
Right,
so,
especially in such a volatile situation in the market.
Exactly, the market is like this, so we want to be able to occupy our niche and have that capability we have, and we're slowly adding to it. We expect by the end of next year we'll be about 20. We may go bigger, we're not sure.
Yeah. Yeah, I heard that the UK government claims that they want to have a 10% share of the global space industry in the next, by 2030, is it?
That's correct, yes.
Yeah.
We have these big visions in the UK,
Right.
and the UK government's been very good at supporting us and others in the UK. So yeah, we're very pleased.
Yeah. And where are you based?
So we're based in a place that nobody's ever heard of. It's called Borden. It's halfway between Guildford, where SSTL are, and Portsmouth, where Airbus are.
Okay,
which is great because we just hire
halfway
all our
between
people.
them, yeah. Great.
Yeah, but no, it's a nice place. So, we have little bits of military space near us as well. So Airbus have some interesting stuff to do with the Skynet constellation. But, you know,
Skynet, I like the name.
I know, it's nothing to do with the Terminator. This is the UK's military SATCOMs.
Great. Well, great. Thank you so much, Doug. It's been a lovely conversation with you. And yeah, wish you all the success for the first mission and having more and more missions next year. Cool.
Thank you very much, Andrey.
Great.
Pleasure to talk to you.
Cool.